Thanks for coming over here. And today, I think I was at a Max keynote. It's more about database. So this one is actually, hopefully you get a chance to zoom out. What's the role of data, right? Why do we even care about the data? You will hear from me that, I think everyone knows that ChatGPT is one of the hardest thing. And I think for the next 5 or 10 years, data is probably the most important thing, more important than even the model itself. I'll get to some of that. First, just a little bit about myself. I was one of the, since most of the people here are technical guys, I was one of the earliest guys at VMware back in the days, 20-some years ago. My claim to fame is I wrote the first line of code for VMware's networking stack. So that's kind of this is my, founder and then CEO. This was like right before I joined VMware. I worked for Vinsurf, the guy who invented the TCP/IP back in the days. And then about 9 years ago, 2015, I joined Greylock as an EIR. And among other interesting things I did, two things I did. One is I started a company after that. But the other thing is, this is 2025, August. You probably didn't know what happened exactly August 2015. OpenAI started. So Elon Musk and Reid Hoffman were recruiting first 10 people in August. So I happened to witness the creation of OpenAI back in the days. I had nothing to do with it. It's just Reid Hoffman was my colleague at the time, and OpenAI started. And 2020, some of you may actually know, I actually wrote up quite a few things 2020. And I said this, GPT-3 in May or June, I said this GPT-3 thing is going to change the world. The reason I said that, this is not ChatGPT. ChatGPT was November 2022. This was two and a half years earlier. The reason I said that was because I knew what OpenAI was going to do and what they were chasing. What they got in May or June of 2020, 2020 was what I thought they would achieve that, around the 2030. It was like literally, 10 or 15 years ahead of schedule. Of course, no one knew Transformer at the time. No one knew next token prediction would be the mechanism. But that's sort of the vision, they wanted. But it's like a 15, 20-year vision. It's not a 5-year. So in 2020, I was like, wow, this is amazing, and then the rest of the story, ChatGPT, and then so I was very lucky to sort of get a chance to witness the creation of the OpenAI at the time. I started an AI company after that, and then which was acquired by Zscaler. And then in my copious spare time, I do podcasts, I do investment. But anyhow, let's get to the real thing of it. The title of the topic is the new Moore's Law for the AI services. So why do we even talk about it? Let's first look at this chart. What can you read out of this chart? I don't know if people can read, but so just to give you a sense, this is 0%, 200%, minus 100%. There are different things. The top one, hospital services, college tuition, college textbook, medical care, child care, food, housing, new cars, household furniture, clothing, cell phone, software, toys, television at the bottom. What do you think about this chart? Like, what do you get out of it? So services are more expensive. Right, by the way, this is from 2000 to probably 22, whatever. So yes, services are more expensive. What else? So what other insights, or what other, what do you think? By looking at this, what other things come to your mind? Electronics are cheaper, right, over the 20 years. Anything else? So maybe I should ask a question. Why, the services like hospital service, education services are more expensive, like 200, 150% more expensive than 20 years ago. Why is that? What?
Human capital is expensive.
Human capital is expensive.
Price always is a balance of request and proposition. The real, usually case of price getting up is always because the demand is rising.
The demand is rising, okay, but why demand was not rising before? But anyway, that's a good thought. I'm sorry?
Not a fixed cost business like SaaS, which means like if you want to scale, if you want to serve more people, you need to add more people into it. So it's a linear cost service. And for the cloud or IaaS, it's a fixed cost. Once you cross some threshold, it's like money printer.
Yeah. There is a scaling, benefit, while for services, there's no such scaling benefit. Anyone?
Regulation?
Maybe it's harder to automate.
Harder to automate, yes. Okay, cool. Last one.
Their technology is not good enough.
Technology is not good enough. So it's actually very, this is actually, I do this, I give this talk at many places, Stanford, Berkeley, Fortune 500 companies, all hands meeting. I've done that, almost on a monthly basis. I try not to do too many, but, roughly, this group actually so far give me the best answer. It's pretty much all of the above. If you sort of think about what your other people have been talking about it, just to keep that in mind, right? The services, it's kind of hard to automate. It's kind of based on rare, human resources, and then it's tailored service. You do one thing for one person, right? Doctor service, education may not be applicable to another group, another country, another thing. It's not standardized, and then there's why television is like going this way. What's the reason?
Competition on the
Competition, but there's something more fundamental.
Economies of scale.
Economy of scale. There's something more fundamental.
You mean subscribing?
Remember the title of my slide? Moore's Law, right? So Moore's Law is really the thing. So I was asking, why is the bifurcation of the price changes? You sort of already gave me the answer. I think fundamentally it's the Moore's Law that's give you that bifurcation. Things here much closer to Moore's Law, and the things there, Moore's Law is less applicable, right? You can't just scale human at a Moore's Law. What is Moore's Law for those people? Just review that, right? Basically, it's kind of a chip capacity increase that every 18 months or two years with very minimal cost increase. Basically, over the 30 years or 20 years, you basically the capacity increased by 1 million times, but still the same cost, right? That's roughly what this is. That's why TV, is very much a Moore's Law thing. Keep in mind, it's very much a chip level concept. There's one problem with the Moore's Law in the last 30 years. Chip is getting less and less expensive, but human is not, right? Many people here are a database or a data guy or whatnot. Your salary didn't, go through the Moore's Law, gets, less, every year. So it creates a problem. Why it creates a problem? Because fundamentally, if hardware, gets cheaper and cheaper, if you are able to scale software engineer just like Moore's Law, then you can write applications left and right. But because you don't have that benefit, what happens is in the 70s, we wrote custom software, right? You have a need, I wrote software for you. And then, in the 70s and 80s, people realized that doesn't scale. I cannot possibly write custom software. So I have to write a generalized software, right? Now you see Windows, Office, then SaaS, Salesforce, Workday. Your Workday is almost the same as my Workday. Of course, I can customize it, but your software is my software. Mostly because hardware gets more cloud, all that sort of things gets Moore's Law is applicable, but software is not. And so that's why you see general purpose software for the last 30 years. That's the fundamental reason for that. But that's a traditional Moore's Law. So we are in the 2024, right? If you ask Jensen Huang, because I was at a place that Jensen Huang was giving a talk. He even said that in that place, and he said that in many public places that he basically said that Moore's Law is dead. But if you really listen carefully, right, what he said about things, what he really said is a chip level Moore's Law is dead. But system level, data center level, Moore's law. I mean, he doesn't call it the Moore's law. He just said, Moore's law is dead. But if you think about the chip system level or the data center level, the so-called Moore's law is actually going as strong, if not stronger than before. If you think about what Elon Musk built 100,000 GPU cluster, Meta announced yesterday they are going to build one as well. This system level concept capacity is actually, at that level, is actually doing better than Moore's law. The other thing is software is going to be done by both humans as well as AI, let's face it, right? AI has already started generating a lot of code. So what I see the next 20 years is custom software will become more reality than before, because before it's not even possible, because there are only order of magnitude 4 million developers, programmers on the planet. We have 8 billion or however many billion people, right? This is such a scarce resource. But with AI, with programmer together, we are going to be able to do the custom software. And then that goes to the next slide. If you think about the standard software we have done, we have seen in the past, we are going to see a lot more customization. So Coursera, right, it offers one class to millions of people in theory. But why my class is the same as yours, right? Because my understanding of certain things may be faster or slower, than you. My background information, my whatever, right, my pace. So I want different classes, from the one you got, from Coursera, which was not possible in the past. But those kind of things, education, healthcare, any kind of thing, these days one of the hot things is about precision medicine, or personalized medicine. Like why aspirin is a good invention. But why you would take the same as mine, right? Our health condition, our situation, our everything is different. It doesn't make any sense for you and I have the exact same aspirin. Now it's kind of now becoming possible. In the past, right? If you wanted to have personalized medicine, you need a lot of software developers to, behind the scene do X and do Y and do Z, which is not even for you to imagine. But moving. In the future, those kind of the personalized, the long tail, contextual to yourself, multimodality services are going to be a more reality. So my if there's one thing you can take away from this session is, last 30 years, 40 years, it's all about general purpose software. I believe that the next 20, 30 years is going to be a lot more about the tailored custom software. That's what human beings, we as a society, we need. Again, healthcare, education, and then remember all those things, right? Hospital services, education, those things, you still need a human to do a lot of whether human in the loop or whatnot, but at least it's possible for us to think about those things. By the way, how much time do I have? Okay, cool. So. There are always 3 keys to the AI: data, algorithm, and then the compute. Compute is a big deal. That's why NVIDIA stock is great. But compute is not only constrained by the GPU. Actually, I think we are roughly, whether NVIDIA says that or not, I think, we are roughly at the tipping point that the GPU is not going to be the bottleneck. The connecting them, cooling them, finding a place to host them, those things will become, or is becoming the bottleneck. If you look at, what Microsoft, what Meta, what everyone's doing, right? They are trying to get a cooling space, and then they are trying to get the data center space. So one of my friends is a senior executive at Google, and then he said, well, we are chasing the data center left and right, and then he told me that this is a crazy world, and then and how crazy it is. One day, he flew to a place of nowhere, in the country, and literally nowhere from his point of view, and then showed up in the morning, and then went to the data center, negotiated a deal, right? I want a data center. And next thing he saw was Satya Nadella, Microsoft, the CEO, showed up. This is a place of nowhere in the country. And Satya showed up next to him and told the guy that, I'm the CEO, I can sign the check right now. That's how crazy, the data center space is, right? Yep. It's more than that. It's also electricity. If you look at, Jeff Bezos, Amazon, they bought a nuclear-powered data center just a few months ago. If you listen to Elon, Sam Altman, they all said, electricity is going to be the bottleneck. So I'm going to just talk about, give you a sense about what's going on, right? One is GPU, the other space, and the cooling electricity. It is shifting from GPU to that. Now, of course, it's actually oversimplified view. Why is that? Because GPU, depending on what you mean by GPU, if it's a single GPU, I think it's, we are kind of no longer see that being the bottleneck. It's still very hard to buy GPU, but it's going to be, okay. But interconnecting them, making that 100,000, 10,000 of them working as a system, and then relatively reliably, not like, utilization is only 10%, 30%, and that becomes the, if you look at the whole system, that's still a bottleneck. But besides that, it's more than just the GPU thing. But that's a computing bottleneck. I don't know how many of us, in this room is going to make a huge difference other than paying NVIDIA that tax. The other thing, we as an industry, we can, in theory, we have some control, which is the algorithm, right? Everyone knows that a ChatGPT is based on this transformer model that was invented by Google. All of you probably heard, Eric Schmidt, ex-Google, was talking about, hey, why Google cannot catch up on the AI stuff with OpenAI. He said, well, Google people maybe just, too much work-life balance, a lot of the controversy, and then eventually he said, I didn't say that, well, I didn't mean that. But the important part is Transformer was invented by Google, but they couldn't make as big deal out of it, which is sad from Google's point of view. The question is, what's next? Is a Transformer going to be the prevailing still? Is it still going to be the model for the next 5 years, 10 years, for a long time to come, or hey, within 2 years we are going to see very different things? That's almost $1 trillion question. I don't know the answer. But there are two ways to think about it. One is, there are so many optimization you can do, and then there are so many. Transformer model, it's mostly, still very much, it's not a diffusion. It's not super good. It's not a multimodality model native enough. So some people are thinking about it. Maybe we should marry the transformer model with the diffusion model, whatever. In some ways, Sora is a little bit of towards that direction. So there is a hope that there is some sense that this model is going to be a non-transformer in the next few years. But another way to look at it is, I don't know that's necessarily going to be true, because there is such a strong ecosystem around the transformer. People writing paper, building hardware, doing all of that. One example I always use is like if you think about IPv4 and versus IPv6. 20 years ago, everyone says IPv4 is going to die and IPv6 is going to prevail because it's so obvious technology-wise, everything. But guess what? 20 years later, everyone's still using IPv4 for most part. So I don't know the answer, but that's sort of I think as an industry we're struggling. The next thing is actually more interesting for whether for this group or for the industry in general, actually, not just for people working on data. Assuming for a second the transformer model, it's going to stay computation. It's more like people figuring out the cooling space. But this is actually where the computer science, where a lot of the things are going to happen. The ChatGPT was for most part, was built off the internet data, Wikipedia, Reddit, all those sort of the things you can, get off the internet. And then we got a ChatGPT, right? GPT 4.5 and then GPT-4. This morning, 3 hours ago, they released the next generation Strawberry. But most of that is, the data is internet data. If we wanted to go 10x, 100x more from here, of course, we want a 10x, 100x computation, right? That's why we are building, we as an industry from 10,000, GPU together now 100,000 GPU over. But it's not just the computation. You need to feed lots of data. If your data quality, if your data volume, if your effective data is not increasing 10x, the computation doesn't really matter as much. So a lot of the game, I would say, with the data. But the question is, where's the data from, right? Whatever data we can scoop from the internet, it's gone. Well, no, it's already utilized. What more, right? There are so many people said that that's it. We run into this bottleneck, and then there are people said, no. There's so many things we can do, right? We can curate the data. We can, have people, just create a data. For instance, this is Mountain View. If I ask, hey, what is the best, what kind of trees should I plant in, if I'm a resident of Mountain View? Probably you cannot find easily on Reddit or, but you can have humans, right? Literally, you can go to, go ask, the Mountain View resident, hey, what kind of trees do you plant here? Are you happy with it? Or, what's your experience, right? So that's very much more expensive way of getting data, but, I believe that, that's inevitable. There was when ChatGPT came out, there was some, sort of a whether joke or whatnot. People say, well, in the future, the robots is going to sort of prevail, and the human just doing the label data be their slaves. I don't think it's that bad whatsoever, seriously. But there is a truth, in my opinion, that the next 5-10 years, the data labeler is going to be a job. It's not a low quality job, by the way. It's not a minimum wage job. It's actually a very high paying job, by the way, in my opinion. And then there is also a lot of controversy about synthetic data. In my opinion, it's kind of very weird. Even Nature, very good. They published something. They said synthetic data doesn't work because once you put the synthetic data, model performance actually decreased. I think that's a wrong way to think about it because we never ask you to, you have to qualify the data, right? You can't just, input, output, and then feed it back. You have to do a lot of the qualification, you have to do a lot of the selection, you have to do a lot of the curation after that. You can't just naively, use the synthetic data. So I think in some ways, I believe that synthetic data has tremendous value, but don't use that naively. So I think there is a lot of that. What I'm trying to say is data is the bottleneck, but there's so much computer science, so much labor stuff you need to do.
I just had a critique on the Moore's law that you have presented, if that's okay to speak for 30 seconds.
I'm sorry?
The Moore's law, you have discussed the Moore's law. So I think a lot of laws that we discussed, there is a bias that they all came from the European background, like the Pythagoras theorem. So the theorems were existing in the world from everyone else. Okay, so let's say experiments on monkeys, they have been done around Japan as well. But we only know it by the name of Jane Goodall, who is a researcher at Stanford. So I think when we discuss the Moore's law, we can discuss the expansion in the auto industry, how were the cars or the custom cars in 1800s, like Rolls-Royce. And then we have a general purpose cars, right, like Ford and Toyota. Now, are you again going to go towards the custom cars? So similarly, the same theory should apply if we are all humans, we have the same instincts on the software. When it comes to the customized software versus general purpose software, what percentage of the cars?
Look, I think there are so many ways we can talk about Moore's law. My general thesis is where Moore's law is applicable in the last 30 years. I don't know if you were in the room at the time, but I believe that the next 20 years is more about custom software because of AI is going to play a role. Now, for the AI to play a role, we need to figure out where's the constraint, right? From the compute point of view, from data point of view, from the algorithm point of view. So my thesis is really, where things are going, where's the bottleneck, which area people have, I think what you are talking about is some use cases. Sure, there are so many different directions you can talk about this topic. It's outside the scope of, my talk here. Okay, so I think let me try to, so there are 3 technical aspects, but there is 3 very, non-technical aspects. That's even more important in my opinion, talents. It's not about, it's more about, talents who can move the needle. Because I lived through the dot-com days, right? Dot-com days, it's crazy that you start a company, you sold it the next day, X million dollar per person. You are laughing probably. We went through all of that together. It's kind of crazy, right? And then there is a Wall Street hedge fund manager asked me, hey, Howie, do you think it's kind of the dot-com all over again? I said, no, this time it's a very different. There is a real thing. Except the one thing I think, I felt like this is dot-com all over again. And it's actually even worse than that because, in the dot-com days, we're talking about how many millions dollars per person. And then now it's actually, we're talking about how many billions per person, believe it or not. If you think about Ilias started a company, 10 people raised the money for $10 billion at a $50 billion valuation. That's $5 billion per person. It's kind of a crazy. But, it actually gives you some sense that, talent is actually a bottleneck. The other thing is the use case. I don't believe we actually found a good enough use case for the Gen AI. If all the Gen AI stuff, use cases are what we are talking about, I think we are wasting all the energy, right? We are kind of wasting the time, and I think we can do much better, but I think we haven't got to that yet. And then process and the culture is another big thing. In the same talk that Eric Schmidt gave, that it's sort of people paid attention to what he said about Google people, work-life balances. I think the best part is not Eric Schmidt talking about that. It's actually the professor, after Eric Schmidt left the room, he said something very profound in my opinion. He said, when a new transforming technology comes, if you just put the technology in in the old process, it's not going to do a lot of the value for you. Case in example, 1850-ish, right, when electricity was invented, they put that in where the steaming sort of the engine was. And it turned out that for the next 10 years, they didn't see much value out of it. And then with the hindsight of the last 150 plus years, that electricity is useful not because electricity is in the central place. It's actually all over the building or everywhere. That's why we invented the fridge or the microwave and everything associated with it. So not like just to replace with the steaming engine, right? So in my opinion, we invented a generative AI. Don't just apply this to our current process, our current culture, but we are still in that stage. It wouldn't take another 30 years for us to invent the equivalent of the dryers or the microwave. Probably 5 years or that, but it's not going to be. We're not there. So that's roughly my thesis. Talent and use cases, those are the 5 big the acquisitions. If you count the per person, the valuation, it's roughly billion or $0.2 billion per person. That's pretty scary from that point of view. And if you think about the use case, not many use cases, Carrot.ai is probably the best use case that we have seen. And if that's the only thing, I think we are wasting our energy. So I think we are. The bottleneck is actually finding the use case and then the talent. And then this is what I meant. This is what Eric, the professor, mentioned, right? Don't just replace the steaming stuff with the same way. You have to think how to apply the AI electricity in the totally different ways. I'm going to skip this. R&D challenges. Obviously, I'm a big fan of I mentioned the education, right? Long tail services. That's where AI is going to make a big difference. Khan Academy provides a free AI system for all educators in US. I don't know what they do exactly, but the direction makes total sense to me. Remember that line? I want that line to tape off, and then I want more tailored services for my kids and everyone's kids, right? Healthcare, AlphaFold. It's going to find the interesting drugs for all of us. And then self-driving, obviously in Bay Area, you don't need me to convince you this is a lot more real. There's one question about, is AI going to replace all the jobs? This is a 1982 article about PC is going to eliminate a lot of jobs. But if you look at the productivity and the compensation in the last, 20 years, 30 years, actually that's not quite the case. So I'm pretty optimistic about what's going to happen, despite the fact, yes, it is true that AI is going to eliminate a lot of jobs, but it's, we should expect new job categories as well. I'm going to skip that. Jensen Huang always said, not always, he was being quoted as not learning code anymore. Actually, I've been thinking about this for the last 2 years. Should we learn coding? Should my own kid learn coding? I came to the conclusion that Not only kids or the all of us or younger generation should learn coding. I think this is the best time for the programmers. So because all of you work with a lot of programmers, right? There are always programmers doing mechanical stuff. Sure, maybe half, maybe a third, or depending on the company. I think they will be replaced. But I think for the rest of the half, or 60% or 70% people, we are going to be, over the time, 10x more productive. So I think we as an industry needs a lot more such. I'll show one last thing. What is this diagram? Take a guess. What is this one? So this is just to give you November 2002. May 1997, this is 0 minus 1,000 to 7,000. What is this diagram? It's not NASDAQ, it's stock. Which stock? Cisco, what else?
Maybe more.
Which one?
Microsoft.
Microsoft, what else? Intel. By the way, this is 2002, okay, not 2022. Intel may actually fall into this. What else? Anyone take it? What? Okay, Amazon. So Amazon stock went this way. And then whatever the thing we saw, it's here. It's nowhere to be seen. My last thing is like AI transformation is ahead of us. There probably will be a bubble. I don't know. NVIDIA will still be the number 1 stock or number 2 stock or number 3 stock. But to me, it doesn't matter. In the end, I think some of the companies will actually prevail. This is the same thing I kind of, this is actually Lisbon in Portugal. I was there right before pandemics. I was like, wow, I live at the wrong time because I want to live, 500 years earlier so that I'm in the age of discovery. But guess what? I actually think, 5 years later, I think we live in the best time. We live in the better time than 500 years ago because right now is the age of the discovery. So if anything, the personalized service, data bottleneck, and then the rest of the things is actually good. Thank you.